Hi, my name is Jacob Smith, and this is my presentation over cloud computing. First, we have virtualization platforms. Virtualization platforms are user-friendly computers that run on more complex platforms, meaning what users interact with on a day-to-day basis, you don't have to have a lot of experience knowing or have hands-on experience with. The complexity of that device or of that system is underneath the surface. It combines virtual hardware platforms, storage systems, and network sources together, acting as one piece of hardware. Virtualization platforms can be carried out on any platform, and the most common form is an operating system, which, for example, is Kali Linux or Microsoft Windows. Now we're going to go into cloud computing services. The first service is software as a service. This delivers a cloud application and infrastructure to the user. It is subscription based. It is a subscription based model for providing software licensing. It reduces upfront costs by eliminating the need to purchase software. Businesses that use this do not have to purchase and install software. It's as easy as accessing the program via the internet. And software as a service provides applications that are pre-configured for users. So the beauty of that is users can plug and play and they can go right to work. There are some threats associated to software as a service. The first threat is the potential user account hacking, and the second threat is data breaches. Organizations have less control over their data, which means attacks are highly likely due to consistent interactions on a day-to-day basis with different users. Some mitigation steps to mitigate these security threats are to enforce multi-factor authentication. This will provide that extra layer of security as individuals or employees log into their accounts, and implement role-based access control. This will limit the amount of users who can access specific data. The next one we'll dive into is infrastructure as a system. The provider of infrastructure as a service, excuse me, manages the infrastructure for the user, while in turn the user manages everything else like the operating system, the software applications, and the middleware. The infrastructure as a service provides a simplified developer experience, and the developer or the user will pay for what they use and how often they use it. The beauty of this is the infrastructure can be scaled to meet the business demands as well. There are some threats associated to infrastructure as a service. With data being out there on the cloud, this is going to be a common theme here. All data is at risk for data leaks or data breaches. Another one here is authentication issues and lack of visibility. Businesses who use infrastructure as a service want to monitor network traffic very closely and restrict access for users who do not need specific access to data. And again, you want to increase the use of multi-factor authentication. Multi-factor authentication should be used everywhere. It should be used in every business, every company, every organization. All it does is provide that extra layer of security as someone is logging into their account. It protects from unauthorized users accessing accounts. Next, we'll dive into platform as a service. This provides hardware and an application to the users, which allows this platform allows users to develop, run, and manage applications. It eliminates the need to build an IT infrastructure, and there is no responsibility on the user to maintain servers or infrastructures. That responsibility falls on the provider. And again, with platform as a service, the users will pay for what they use. Now, like with data being out there on the cloud again, businesses are at risk for data breaches. That means with that data out there on the cloud, it is highly important that businesses use their own security resources to secure that data, to provide extra layers of security over that data. That way, that data cannot be breached or hacked by unauthorized users. And then the last service we're going to dive into is a data as a service. This uses data management strategies to deliver data services over the internet. And again, that is data in traffic over the internet, which we will get to that, but leads to some risks. It requires minimal setup time, which allows businesses to get straight to work. They can get the data as a service set up and then begin processing and storing data. It is more flexible than on-premise options because the cloud can contain a lot more of a workload, and it's not a physical storage. It is a virtual storage, so it can take a lot more of the workload than say something physically on site. Tools and services for the data as a service are managed by the provider. The users do not have to worry about the tools and services, updating them, monitoring them. That's all done by the provider. It also allows businesses to cut down on in-house personnel. This means essentially there's a need for less staff required. There's not as much manpower required around the managing of IT services with data or IT data management. Now, with this being again in the cloud and data being in transit, stored over the internet or virtually, that means this data is at risk for a breach. Again, increasing multi-factor authentication across all login requirements is essential, and it will protect data from being breached. And then restrict access control to those who require access to specific data. This will, again, in turn, prevent unauthorized users from accessing that data and that data getting in the wrong hands of malicious users. We don't want that. Now we're going to dive into the cloud computing models. The first one we have is the public cloud. This supports all users. Most users use this form or this application to develop or deploy and test applications. The users, the public cloud is a shared infrastructure. So what that means is there are all sorts of numbers and amounts and different types of users on this infrastructure. It pulls resources in data centers all over the world, and that allows multiple companies, multiple organizations, and all kinds of users to access that data simply through the internet. And it allows providers are responsible for managing the infrastructure. Users are not responsible for that infrastructure. It's all on the providers. In turn, this reduces IT costs. Now we have the private cloud computing model. Infrastructure is dedicated to a single organizational user. Now, as in turn, private is it's more strict, it's more disciplined, it's more secure than a public network. The it can be hosted in three different ways. It can be hosted through the organizational data center, through a third party, or through a private provider. And then the user is responsible for the operation of the private cloud. That means software updates, upgrades, running patches, installing patches, and using the operating system. The user is responsible for all of that. It also provides an enhanced security due to the controlled amount of the controlled traffic. It's private, so not just anyone can access it. This reduces the network traffic flow. And then it also reduces the workload on the system or on the network, which increases performance. And then that makes the performance predictable because there's more restricted flow, which is easier to monitor. Next, we have the hybrid cloud, which is a mixed computing environment for applications. It enables the migration and management of workloads. It can go from public to private. This reduces costs, minimizes risks, and extends capabilities, It allows for on-premise use and other flexible options. So you can use physical storage, physical access, and you can also use the cloud to essentially extend the capability. And then it improves performance and reduces latency. And then finally, we have the community cloud computing model, which is, from what I've read and from research, it is something newer. It's an infrastructure where multiple organizations share resources. Members are organized according to business needs, so similarities, you're grouped in similarities. It is a modified form of a private cloud, and it is owned, managed, and operated by members. However, it's more expensive than public clouds, but more secure. Uh, and this in turn makes scalability more challenging. It's more secure because there is a limit on how much data storage a user can have. So it's not just anyone can come on and join. You have to be a part of the community, and then you are restricted on what you can do within that community and what you can store within that community. Next, we have service-oriented architecture. This is used to make software components reusable and interoperable. This is a service that is used to help other services communicate with each other from different platforms and different systems. It integrates software components that are deployed separately. So they've been deployed apart, they're separate, and it allows them to come together and communicate. It's become integral to the cloud computing world, and it is an enterprise, so it's a wide approach architecture, and it reduces cost and complexity associated with enterprise software. Finally, these are my references. These are all the sources that I used to dig up the information and provide this presentation to you. Thank you for your time and thank you for your attention.